Hi everyone, welcome back to Life Technologies YouTube channel, and thank you for watching and supporting our channel. So if you are watching these videos or if you have watched our videos and you are yet to subscribe to our channel, kindly hit that subscribe button and stay tuned for more upcoming videos and also to support our channel. So this is another episode of our IPRAN training series. And remember, in this series, we discuss the IPRAN architecture. We discuss the general overview, the setup, the general physical setup of IPRAN network from the CSGs, ASGs, and the RSGs. And also, we discuss how to deploy different protocols, the IGP, ISIS, and even BGP and MPLS on IPRAN network. We've also done lab simulations on the same just to give you a better understanding of how to configure different protocols on IPRAN network. So if you haven't watched our previous videos and you are interested in understanding how IPRAN network is deployed, kindly check them out on our channel. So in this episode, we are focusing on how to deploy the HoVPN architecture. We'll be doing a lab simulation of how to configure HoVPN on Huawei routing devices. In our last episode, we discussed the HVPN solution, the hierarchical VPN architecture that is normally deployed on service provider networks. So we mentioned that with the HVPN solution, it makes our network more scalable and also allows us to deploy low-end devices as the CSGs or the UPEs in this setup. So if you haven't watched our previous episode, kindly check it out on our channel. It will give you a better understanding of the HVPN solution and the two types of HVPN, the HoVPN and HVPN solution. So this is the topology that we are using. You can see that we have different nodes. In this topology, we have 6 routers. So we have UPs. We have 2 UPs acting as CSGs. We have 2 SPEs and we have 2 network provider edge routers. And then we have the VPC. The VPC will be representing the controllers for different technologies, 2G, 3G, 4G, and 5G. And then we have the BTS. So these are the radio equipments. So we have the BTS connecting to the UPs, the UP connecting to the SPE, and the SPE connecting to the NPE, and then NPE connecting to the VPC. So we can have an end-to-end simulation of the IPRAN network by deploying the HoVPN solution on this network. So for the protocols, we are using ISIS. You can see that we have ISIS 100, which will be our aggregation ISIS. So ISIS 100 will be configured between the NPEs and the SPEs. So that will be the aggregation process. And then we have our access ISIS process. So we have ISIS 10 that will be running between the SPs and the UPs. And of course, we will be doing the same implementation that we have done before in our ISIS implementation on IPRAN network. We need to do route import between the different access and aggregation ISIS process. So for the BGP configurations, we need to configure BGP peering sessions between these nodes. So we'll be configuring BGP peering session between SPs and UPs. So SP01 will peer to NP01 and NP02. Similarly, SP02 will be peering to NP01 and NP02. We also do BGP peering between the SPs and the UPs. Remember, these are hierarchical architecture. So SP01 will establish a BGP peering session with UP02, and also UP02 have to establish BGP peering session with SP02. Similarly, UP01 will have to establish BGP peering session, that is the MPE IBGP peering session between UP01 and UP and SP02. So once we have our BGP peering session, we'll also have MPLS configured. Remember, this is our MPLS backbone. All the way from here, it will be acting as our MPLS backbone. So we need to configure MPLS and activate MPLS and LDP on the interfaces that will be participating in our packet forwarding. So for the service configuration, we have these configurations here. So we have 2G, 3G, 4G. We'll be using VLAN 100 for 2G, VLAN 200 for 3G, and VLAN 400 for 3G for 4G. And then we'll be using a subnet of /29 for the service configurations. So we'll be configuring our gateways on the UPEs in the respective VPRNs or the VPN instances, and then we also need to do configurations on the BTS so that we can have the routes advertised into BGP. So remember, with the HoVPN solution, the SPE has to only advertise a default route from the SPE to the UPE. So the UPE should only be learning the default route for 2G, 3G, and 4G services. So that is the objective of this lab, and we'll be doing the implementation step by step so that you have a better understanding of how to implement HoVPN architecture on Huawei routing devices. So for the configuration steps, we need to do some preparations. Remember, before we deploy the services, we need to do the basic configuration. We need to have IGP for reachability. We need to have MPLS, LDP for label distribution, and then we are using label switching. So we need MPLS and LDP. And then for us to be able to exchange service routes, we need BGP. So we'll be configuring BGP, we'll be configuring ISIS, we'll be configuring MPLS, and then MPLS LDP, so that we have the setup ready for the services to be deployed. We also need to configure VPN instances. Remember, we are isolating services in different VPN instances. So we'll be creating a VPN instance for 2G, a VPN instance for 3G, and another VPN instance for 4G. Then respective services will be configured in their respective VPN instances. So for the configuration steps, our step 1 will be to configure system name, interface IPs on the router. So remember, we have interfaces on these interfaces connecting different nodes in this setup. So we'll be configuring the system name, which is always a best practice, so that it's easy to identify the nodes. And then we need to configure IP addresses. We'll be creating the loopback 0. You can see the loopback 0 IP addresses for different nodes. And then we have the point-to-point IPs also assigned for different nodes. Once we've done the IP address configuration, we need to configure IGP for UPEs, SPEs, and NPEs to communicate and learn each other's loopback addresses. So remember, we need reachability. Before we are able to deploy BGP on this setup, we need to be able to ping the loopback 0 of different nodes. So UPE01 should be able to ping the loopback 0 of SPE01 and SPE02. Similarly, SPE01 should be able to reach the loopback 0 of both UPEs and the NPEs. So that's why we need to configure IGP. And I've mentioned that we are configuring different access and aggregation ISIS processes. So once we've done that, we need to do route import between the different access and aggregation ISIS processes and test to see that we have reachability between different nodes. After the IGP configuration, our step 3 will be to configure MPLS, MPLS LDP on the UPEs, SPEs, and NPEs. So this will be our step 3. We need to configure MPLS, MPLS LDP on UPEs, SPEs, and NPEs. And once you've done the MPLS activation, you need to also activate it on the interface. So the interfaces will be activating MPLS, MPLS LDP on all the interfaces in our MPLS backbone. Step 4 will be to configure VPN instance on the UPEs, SPEs, and NPEs. I mentioned that we are isolating or segmenting our services into different VPRNs or VRFs. So we'll be configuring 3 VPN instances, doing proper planning for the route distinguishers and the route targets. And step 5 will be to establish MP-IBGP peer relationship between UPEs, SPEs, and also between SPEs and NPEs. So once we've done our MP-IBGP relationship, we'll confirm that our peering sessions are established. And step 6 will be to configure static default route on SPEs. Remember, for SPEs to be able to advertise a default route to the UPEs, it should have this route in their routing table. If they don't have this route, by default, BGP will not be able to advertise this route. So that's why we need to configure some static default route on the SPEs. And step 7 will be to configure SPEs to advertise default routes to the UPEs. So that is the stage that we focus on for the HoVPN solution. And then finally, we need to configure services on UPEs and test reachability. See how routes are being advertised from UPEs to SPEs to NPEs, and also the reverse route advertisement from NPEs to SPEs to UPEs. And finally, we need to test the communication from the BTS to the NPEs and verify that everything is okay, all route advertisement are okay, and everything is working fine. So I've already configured everything in our topology, but we'll go through the configuration step by step. So this is the topology setup. You can see that I mentioned that we have NPEs, SPEs, UPEs, and we also have the site BTS. So we have BTS 1 and BTS 2. So for the first step of our configuration, I've mentioned that we need to do interface configurations. So we'll be starting with the NPE configuration. So we need to be able to configure the interface IPs and the system name. So you can see that we have the IP address planned for different nodes. So the first step will be to configure the sysname. And remember, you always have to be in the system view. And once you've configured the system name, we now start configuring the interface IP. So this is the interface gig 00 and then gig 001. And finally, we have gig 002. And we also get loopback 0 interface and assign the specified IP address. So on NP01, we can verify that we have the IP address configured, display IP interface brief. So we have the interface configured on different nodes. We have our loopback 0 with 1.1.1.1 and then the point-to-point IP configuration on the 3 interfaces connecting different nodes. So we move to NP02. So for NP02, we are doing the same. We are configuring the sysname and then we are doing interface IP configurations. So we have gig 00, we have assigned the specified IP address, and then we have gig 002, we also have the configured IP address, and the loopback interface, we also have 2.2.2.2 mask is 32 configured on this interface. So when we check on NP02, we expect to have the interfaces with the necessary IP address, display IP interface brief. You can see that we have IP address assigned to 0.0.0 and then we have another IP address assigned on 0.0.0/0/0/0/2. So these are the IP address assigned for the interfaces, and we have 2.2.2.2 mask 32 on the loopback 0. So we do the same for the other routers. We have SP02. SP02, remember, it's connecting to 3 routers. SP02 connects to NP1, it connects to SP2 and UP2. So we need to do the necessary configuration. We configure the sysname, and then these are the interface IP configurations. We have gig 00, gig 001, gig 002, and the loopback IP address. So we can verify this configuration on SP1. We run display IP interface brief. So we have the IP addresses assigned on these 3 interfaces, and we also have IP address assigned on loopback 0 IP 4.4.4.4 mask is 32. So we move on to the next stage. This is configuring IGP. So when you check on the UPEs, we have also configured the necessary IP address, display IP interface brief. We have the IP address assigned, we have gig 00 and gig 003 connecting the different routers, and then we have loopback 0 configured with 6.6.6. We can also verify on UP1, display IP interface brief. We have gig 00 configured with this IP, gig 003 configured with the necessary IP, and then loopback 0 configured with 5.5.5.5. Mask is 32. So we've finished configuring the interface parameters for the IP addresses. So the next stage will now to configure IGP. So for IGP, I mentioned that we are using one access process and another aggregation process. So we are creating ISIS 100 on NP01. IS level, we are configuring all routers in level 2. Then we are setting the core style to wide, and the network entity is set to this one, which is derived from the loopback 0 IP address. And then we are configuring the IS name for ease identification of this session. Once we've verified these, we are activating ISIS on the interfaces. So we activate ISIS on gig 00, gig 002, and loopback interface. So you can verify that these are the configurations on NP1. If I display, so if you want to check just configuration for a specific parameters or a specific protocol, you can run this command, display current configuration, configuration ISIS. You can see that these are the configurations of ISIS on this router. Can display ISIS 100 interface. So we have activated ISIS on these three interfaces, gig 00, gig 002, and interface loopback 0. So these are the configurations on NP01. On NP02, we also need to create ISIS process 100. IS level is set to 2, core style is set to wide. The network entity derived from loopback 0 interface, and then IS name set to NP02. And we are activating ISIS on the three interfaces interconnected between the different routers. Loopback interface is also activated with ISIS 100. So from this NP2, I can display ISIS 100 here. Display current configuration, configuration ISIS. So we have ISIS 100 configured. I can display ISIS 100 interface, display ISIS 100 interface. We have these interfaces activated with ISIS 100. So the next stage of our configuration is to configure SP01 and SP02. So for SP01, you realize that we have two ISIS processes. So we are running multi-instance ISIS. We have ISIS 10 and ISIS 100. So ISIS 10 for access, ISIS 100 for aggregation. So the name is set to SP01 on both processes. The network entity is set to the system ID is derived from loopback 0. All levels set to level 2, core style set to wide as usual. So we activate ISIS 10 on the interface facing the UPE, and ISIS 100 on interfaces facing the UPE, the SPE and also the NPE. And loopback 0 is activated with ISIS 100. So we do the same on SPE2. SPE2, you also create two ISIS process, ISIS 10 and ISIS 100, and activate it on the interfaces. So we activate ISIS 10 facing the UPE, ISIS 100 facing the SPE and NPE, and also we activate ISIS 100 on loopback interface. So for verification, we can verify that on SP01, display ISIS interface. So we expect to have, we have one interface in ISIS 10, and then we have three interfaces in ISIS 100. Can display current configuration, configuration ISIS, as we've done before. You see that we have ISIS 10 and ISIS 100 configured on this node. SPE2, we expect the same, display ISIS interface. We have one interface in ISIS 10, we have 3 interfaces in ISIS 100, display current configuration, configuration ISIS. We have ISIS 10 and ISIS 20 configured on these nodes. And then finally on UPEs. So for the UPEs, we have the same. We have only created one access ISIS process, ISIS 10. Still same level 2, core style set to wide, network entity generated from loopback 0 interface, IS name set to the system name of the router. And we activate ISIS 1 on the interfaces, ISIS 10. So on UP02, we do the same, create ISIS 10, activate it on the interfaces. So we can verify this on UP1, display ISIS interface. We have 3 ISIS interfaces, display current configuration, ISIS. We have ISIS 10 configured. On UP2, we can do the same, display ISIS interface, display current configuration, ISIS. So you can see that we have ISIS 10 created on this router. So we can verify that our ISIS configuration are okay. So the next stage is to verify our ISIS peering status. So we'll start with NP1, can display ISIS peer. You can see that we have 2 peering sessions. We have a peering to NP02 and SP01. On NP02, we also expect the same, display ISIS peer. We have 2 peering sessions. On SP01, display ISIS peer. So on SP01, we have 1 peering session in access ISIS process, and we have 2 peering sessions in our aggregation ISIS process. On SP02, we can verify the same, display ISIS peer. We have 1 peering session in access ISIS process and 2 peering sessions in our aggregation ISIS process. On UPEs, display ISIS peer. We have 2 peering sessions on the access ISIS process. So we have peering to SP02 and UP02. On UP02, we can do the same, display ISIS peer. We have 2 peering sessions, display IP routing table, display ISIS route. You have the routes from ISIS NP1. You can also display ISIS route. You have the routes. So we can verify that our ISIS is well configured. We can try to ping, for example, from UP1, we can ping the IP address of SP2 and also SP1. But remember, for us to be able to ping, there is another process that we did. So we need to do the route import between the access and aggregation processes for us to be able to ping from UPEs to the SPEs. From the NPE, we can also ping 3.3.3. We can also ping 4.4.4. So our connectivity test is okay. We have reachability between different nodes. So I've mentioned that one step that we also have to do is to configure the route import between the access and aggregation process. So these are the configurations that we have used to do the route import between the different routers. So this is performed on SPEs. Remember, SPEs are the ones that are running multi-instance SIS. So that's why we are performing the route import between the different access and aggregation process only on the SPEs. So we are creating an IP prefix to match the loopback interface. We only import the loopback IP to the access. And then for us to import access to aggregation, we are only importing the point-to-point and the loopback. So we have a route policy configured, route policy to import aggregation loopbacks to the access process. So we are merging the import aggregation loopback prefix, and we go ahead and import these loopbacks to the. For ISIS 100, we are importing ISIS 10. I've mentioned that for ISIS 10, we only need to import the point-to-point IP address and the loopback interface. And then for ISIS 10, we are only importing the loopback interface of the aggregation node. So that's why we are using the route policy import aggregation loopbacks. So this is how we perform the route import. In ISIS 100, we are importing ISIS 10 using a route policy, and in ISIS 10 we are also importing ISIS. We only import, remember, loopbacks of the aggregation nodes are in ISIS 100. So we do it differently. We only import the loopbacks using the direct, and we are using an IP prefix to match that direct loopback that is configured on this node. So we do the same on SP02. We configure the prefixes to match the route that we need to import between the different ISIS processes, and then we configure route policies and do route import between the different nodes. So this is how you perform the route importation between the access and aggregation process. Remember, it's a best practice not to import everything. Don't just import like ISIS 100, import ISIS 10, ISIS 10, import ISIS 100. No, you don't need to import everything between the two processes. So that's why it's always recommended to use the IP prefixes and also to use the route policies to control what is imported between the different processes. So once we've verified, remember we have already verified that we can be able to ping between different nodes, remember our BGP peering session will be established between UPEs and SPEs using the loopback 0, and also SPEs to the NPEs. So SPEs will be able to ping both routers. From here, are we able to ping 1.1.1? Yes, we can. Are we able to ping 2.2.2? Yes, we are able to. So we can also go ahead and test the ping to the UPEs 5.5.5. Is it 5.5.5 SP01? Ping 6.6.6. We are able to ping 5.5.5. Let me see which one is 5.5. This is 5.5. Display current configuration ISIS. We have ISIS configured. From here, we need to ping 5.5.5. We can be able to ping. Display IP routing table 5.5.5. We are learning it via ISIS. So once we have reachability, the next stage of our configuration is now to implement MPLS. So we need to configure MPLS LDP on the UPEs, SPEs, and NPEs, and activate on the interfaces. So I've mentioned these multiple times. Before you configure MPLS, you always have to configure the LSR ID. So once you've configured the LSR ID, and normally we configure the LSR ID using the loopback 0 IP to make it unique, we then go ahead and configure MPLS, enable MPLS LDP. Layer 2 VPN not necessary because we are not configuring any layer 2 VPN in this setup, but later when you start implementing enterprise services on IPRAN network, you always have to configure MPLS L2 VPN. And once you've done that, we can now go ahead and activate MPLS and MPLS LDP on the interfaces as shown. So just to command MPLS LDP. So on NPE02, we do the same. We configure the MPLS LSR ID, activate MPLS LDP, and enable it on the interfaces. We are doing the same for SP01. On the 3 interfaces, we do the same for SP02, configure LSR ID, enable MPLS, enable MPLS LDP, and activate it on the interfaces. And we also do the same for the UPEs. So these are the configuration for the UPEs. You set the LSR ID based on the loopback 0 IP address. So this is 5.5.5.5. We activate MPLS, MPLS LDP, and enable MPLS and MPLS LDP on the interfaces. So if you check on this one, if I display MPLS LDP session, we expect to have 2 MPLS LDP sessions. If I check on UP1, display MPLS LDP session, we also have 2 MPLS LDP sessions. On SPE, we expect display MPLS LDP session. We should be having 3 sessions. On SPE2, display MPLS LDP session. We also have 3 MPLS LDP sessions. On this router, display MPLS LDP session. Remember, MPLS and LDP are only activated on the interfaces in the MPLS backbone. So that's why these interfaces doesn't have MPLS and LDP configured. Display MPLS LDP session, we have the necessary LDP sessions. These are just local LDP sessions established on the routers. So after the MPLS LDP session, we are moving to the next stage. We need to configure VPN instances on UPE, SPE, and NPE. I mentioned that we are separating the different services into different VPN instances, or the VRFs, virtual routing and forwarding. So we have a VPN for 2G, we have a VPN for 3G, and a VPN for 4G. So this is what is configured on the routers. For 2G, we are using the route distinguisher. Remember, the route distinguisher is basically used to make the routes unique and allow different VRFs to have flapping addressing space. So we have 500:1 for 2G, 500:2 for 3G, and 500:3 for 4G. The same route distinguisher has been configured at the route target. So we have different route targets configured for different technologies. You can see that for 2G you have used 500:1, both for export and import. For 3G we have used 500:2 for export and import, and 4G you have used 500:3 for export and import. So these are just the VRF that we have configured on these routers for 2G, 3G, 4G services. If you have other VPNs, you still follow the same process. You just need to do a proper planning for the route distinguishers and the route targets. So once we can verify our VRF configuration, so for the VRF configuration, they have been configured on all the routers. You can use display current configuration. If I run display IPVPN instance, you can see that we have the VPN instances, display current configuration, configuration VPN instance. We have 2G, 3G, and 4G VRFs configured. On SPE, NP, we have the same display IPVPN instance. We have the VRFs, display current configuration, configuration VPN instance. We also have the 3 VRFs configured on these nodes. On the UPE, we have the same display IPVPN instance, display current configuration, configuration VPN instance. So we have the VPN instances configured on the UPEs, the SPEs, and the NPEs. So these are the configurations again. The route distinguisher and the route targets are the key things that you need to do proper planning for it. And then finally, step 6, we need to do the MP-IBGP relationship between the UPEs and SPEs, and between SPEs and the NPEs. So we need to do BGP configurations between the different nodes to ensure that they will be able to exchange the service route that will be deploying on these routers. So for NPE01, you can see that we have created BGP 500. We have configured the router ID and then we are specifying the peer. So in this setup, I haven't used the groups, but when we check the configuration for the SPEs, we have the groups. So we have specified the two peers to SP01 and SP02. We are connecting using loopback 0 interface. We don't need the IPv4 family. We are only using, remember this is MP IBGP, so we are doing the IPv4 VPN before peering between the different nodes. So we have activated the two peers SP1 and SP2. On NPE02, we do the same. Configure BGP 500, AS number 500, that is the AS number that we are using. We have the route ID configured to 2.2.2, which is the loopback 0 IP address. It's always a best practice to configure the router ID manually. And then on NP02, we can see that we have created groups. So we have a group, and this one helps to minimize the configurations, and it's easy to manage. So we have a group RSG to SG group, which is an internal group, and then we are specifying that they should connect using loopback 0, and we have the two peerings, 3.3.3 and 4.4.4, which are SP1 and SP02. So at this stage, we are activating the IPv4 peering between the two routers. So these are the configuration for NP2, SP01. We have groups also. So remember for SP1, we have SG to CSG group because we have SPE peering to UPEs and SPE peering to NPEs. So we have ASG to CSG group that will be for UPE peering sessions, and then we have SG to RSG group that will be for the peering between the SPEs and the NPEs. So again, we are using the loopback 0 to connect, and then we are activating the VPN before peering between the the peering sessions from the ASG to the CSG. So we are using different route policies. This one we'll discuss. For SP02, we are doing the same. We are configuring the two groups, SG to CSG group and SG to RSG group. So it's similar configuration. And then finally, to this one should be the UPE. So this is the UPE peering session. We are only peering to the SPE, so we have a peering to SP01 and a peering to SPE2. Similarly, we have the same setup for UP02. So these are the configuration for UP02 peering to SP01 and SP02. So we can verify our BGP peering sessions on the UPs, SPs, and NPEs. So if I run display BGP VPN v4 all peer, you can see that we have a peering session to 3.3.3 and 4.4.4. On UP1, we can do the same, display BGP VPN v4 all peer. So we have a peering session to 3.3.3 and 4.4.4. On SP1, display BGP VPN v4 all peer. We have peering sessions to the NPEs, the two NPE 1.1.1, 2.2.2, and to SPEs, to UPEs. So we have 4 peering session on SP01. We also expect 4 peering session, display BGP VPN v4 all peer. We also have 4 peering sessions between the different nodes. So for NPE, we check display BGP VPN v4 all peer. We have 2 peering sessions to the SPEs, NPE2, display BGP VPN v4 all peer. We also have 2 peering sessions to the SPEs. So once our BGP is up, we now need to control the route export between the different nodes, especially between the SPEs and the UPEs. So remember that the SPEs only have to advertise the default route to the UPEs. So that's why if you see, you have an IP prefix of default route, So we have configured an IP prefix of default route index 10 permit 0.0.0, and then we have a route policy to export this route policy to export the default route to the CSGs. And we have configured also a preferred value. So we have set the preferred value to the highest, so that whenever it's receiving any other route that is not coming from the SG, it will not prefer that route. It will still prefer the route that is received from the SG or the SPE. So that's why we are setting the preferred value to the maximum 32,768, or you can set it to any value that is higher than the default value. So we have also configured static route. Remember, before the SPE is able to advertise a default route, it has to have this route in their routing table. So if you check on this configuration, we have configured static routes for different services. We have 2G default route, 3G default route, and 4G default route. So this default route will be imported into BGP, and then now the SPE will be able to advertise the default route from the SPE to the UPE. So on our BGP configuration, we have used this route policy to ensure that we only export the default route to the UPE, and then we are setting the preferred value to the highest. So for this configuration, remember, for us to be able to export a route, we need also to have this route. So you can see that we are importing the direct route and the static route. So any route that has the VPN configured to 2G, 3G, or 4G, it will be imported into the respective VPN. So once you have this route in BGP, you can now have it advertised to the UPEs. And we are using the network command and setting the preferred value to 32,768. So we do the same for SP01 and SP02. So these are similar configurations. On the NPEs, we create loopbacks to simulate different networks. So if you check display IP interface brief, you will find that we have this loopback. So if you check the static routes, you can see that they are pointing to these IPs. These IPs are configured on the NPEs. So we have a loopback 100, loopback 200, loopback 300 configured with these IPs. So once the static route is configured, remember again, it should be reachable from the SPE. So that's why we have the static route configured, and then we are configuring the loopbacks on the NPE to simulate networks for different technologies. So you'll find that on this NPE, we have the necessary configuration for the loopback 10, loopback 100, and loopback 200. And display current configuration BGP. These direct routes have been imported into different VRFs. So we have 2G, 3G, and 4G. If I display IP routing table, VPN instance, 2G VPN, I expect to get that route. So I have 10, 10, 10, which is a direct route. So once you have this route on the SPE, it should be reachable, and then the route will be propagated towards the UPE. So the final stage of the configuration is to now configure services on the UPE. So we are creating sub-interfaces for different services. We have UPE01, we create these interfaces, and we bind the VPN instances. So you can see that we are binding the VPN instance and then assigning IP address. If you do the opposite, you will have to reconfigure the IP address. So we have 2.100 for 2G, 2.200 for 3G, and 2.300 for 4G. So we do the same for UP02, and the IP address have been used. So we have used the first IP address available at the gateway. So remember, these are the gateway configuration on the UPEs. So I can verify that I have these configurations in place. Display IP interface brief. I need to configure this. So on UP1, I will copy the configurations. need to select. So these are UP1 configurations. I will copy it. Paste. Display IP interface brief. I have these three sub-interface configured with the IP addresses. I can check on UP2. So UP2 display IP interface brief. I need to do the configuration for the services. This and then paste on UP2. Can display IP interface brief. I have the configurations. So remember, now we are ready to start verifying our route exchange. So on the UPEs, we can verify that we have the default route, display IP routing table, VPN instance to GVPN. You can see that we are only getting the default route. We are not getting any specific routes advertised from any other place. We can also check for 3G VPN. We have only the static route. 4G VPN. We also 4G VPN. We also only receive the default route from the aggregation node. So on UP1, we can also check the same, display IP routing table, VPN instance to GVPN. We are only getting the default route, 3G VPN. We are also only getting the default route. For GVPN, we are only getting the default route from the SPE. On the SPE, we expect to get the detailed route from both the SPE, from both the UPE and the NPE, display IP routing table, VPN instance to GVPN. We have these routes propagated from. You can see that we are learning one route from the aggregation from the access node. We can also check for 3G VPN. We are also getting the routes, the specific route from the access nodes. So this one verify that our route exchange between the UPE, the SPE, and even the NPE. If we check the NPE display IP routing table, VPN instance, 3G VPN, you can see that we have the necessary routes. This block, we are learning it from the SPE. It's advertised from the UPE to the SPE and then to the NPE. So this one verify that our setup is okay and our route import between the different nodes is okay. We are only getting the default route from there. We are only getting the default route from the SPE to the UPE. So I hope you've enjoyed the session, and we'll be diving deeper to discuss how the packet forwarding will be happening on this network, how the route is being propagated from the SPE to the UPE to the NPE, and just try to understand the working principles of the HoVPN solution. Again, I hope you've enjoyed this session. If you've done so and you liked it, kindly like the video, leave your comments in our comment section, and also if you are yet to subscribe to our channel, just hit that subscribe button and stay tuned for more upcoming videos. Thank you. Bye.